Now we're going to look at a visual interpretation of the real number system, and notice that everything, let's see if I can get the whole thing in there. This is the real number system. We have this large oval on this side, and then irrationals are kind of by themselves over there, because rational numbers, this large oval here, includes integers, whole numbers, and natural numbers. So all of these are rational. Irrational has its own space off to the side because irrational numbers cannot fit into any of these other categories. So for example, our natural numbers here, we said those were our counting numbers. So counting numbers, 1 would be a natural number, 4, 10, we're just going to put some counting numbers in here, 392, it can be large numbers. Anything that is 1 or larger and is a whole number is going to be a natural counting number. Now a whole number includes 0, so this 0 would be included. We could still have some of these numbers, 328, 15. It's all of your natural numbers plus 0. So 0 is kind of the key here. We're adding this to it. Integers now include negatives. So once you get to integers, we're going to include negatives. So we have positive and negative numbers. So we could have 0 again. We could have -8. We could have a positive 23. We could have -87. Notice there's no fractions or decimals though. We're still doing whole numbers, but now they can be negative. And then in our final category, we're going to have our rational numbers. So now we can have fractions. So we could have 2/5. We could have 0.6 repeating, which is the same thing as 2/3. We could have the square root of 25 because that reduces to 5 because 5 times 5 is 25. So the opposite of that is a square root. We're going to be talking a lot about square roots this next lesson tomorrow. So we're going to write in here that we could also include square roots of perfect squares. Okay, so square roots are only true if it's a perfect square. So 5 times 5 is 25. You could do 4 times 4 is 16. So square root of 16 would be a rational number. It has to be your perfect squares. That's what's important there. Because when you get over to irrational numbers, it's going to be a square root of anything that is not a perfect square. So the square root of 2, the square root of 11. Anything that is not a perfect square would go in irrational. We also talked about pi being an irrational number. Also decimals that do not end. So 1.2135 and it goes on. That would go to an irrational. We could have decimals over here that do end. So let's say we have 0.13. That would be a rational number because it has a terminating, it ends the decimal. Okay, so these are exact fractions or decimals.